Hey, this one's a design problem. We want to suppose we want to create a tube in which the air column inside the tube will have a natural frequency of corresponding to the note B flat, musical note B flat. Let's draw a tube. Then imagine putting the fundamental frequency in there. I think I'll get a dotted line here for our no displacement from equilibrium position. And then put a curve in there representing a point where the air molecules in their left-right motion experience no displacement from equilibrium. They got no room to go left, and so they go in neither direction. And then over here where we get maximum displacement, we're showing it at an instant, but in this region the air molecules undergo maximum displacement from their equilibrium position, which would be that middle position. Alright, that represents a half of a wavelength, so we can write down the equation 1/2 a wavelength is equal to L, where L is the length of the column here, or length of the tube, and in fact that's what we're looking for. So I need 1/2 of a wavelength is equal to L, meaning the length has to be equal to 2 times, well, the wavelength. Let's put it that way. The wavelength, multiply both sides by 2, I get the wavelength has got to be twice the length. Alright, now we get some information on the speed of sound in the air inside that tube and the frequency. And we know that the speed of sound can be expressed in terms of the wavelength and the frequency. Let's take a look at the formula sheet to get that relationship. We've got speed of sound right here. The speed of sound is equal to the wavelength times the frequency. So we'll write that down. V, the speed of the wave, which is the speed of sound in this case, is the wavelength times the frequency. So we can plug our expression for 2L in there for the wavelength. Should say our expression for the wavelength, 2L, can be plugged in there. And let's say again we're looking for L, we're given the frequency, and we know the wave velocity. So I just solve that for L, divide both sides by 2F, and switch sides at the same time. And now it's just a question of plugging in values. They wanted 343 meters per second for the speed of sound and 466 hertz. 343 meters per second, and then all divided by 2 times the frequency was 466 hertz. Hertz is a reciprocal second. Put that in there. You see that the seconds cancel out, and I'm left with meters for the units. That's good. That's the unit of length, SI unit of length, and I get 0.368 meters. Probably just a little bit shorter than my forearm, maybe from wrist to elbow, about that distance. For the length that a tube has to be in order for the first harmonic in the air column enclosed by that tube, when the tube is closed at both ends, to correspond to a B flat. In other words, have a harmonic, first harmonic of 466 hertz.